Welcome to Math Dog, April 1st edition, episode 6. This is most appropriate for geometry students. We'll be completing the square to graph a circle. But first I have some bad news. We've quarantined Math Dog. She seems a bit sick. She's acting kind of funny. We've locked her in a cage. And she looks a little bit different somehow. I'm not quite sure what's going on with her. Of course, we're hoping it's not puppy corona. Math Dog is just fine. April Fools. Look at the love in her eyes. Here's Math Mouse. I'd like to hold Math Mouse. Ow, it bit me! Now folks, I'd like to review with you how to complete the square to graph a circle. Let's look at the original problem. You'll see something like this. And you will have to end up with a circle that looks something like this. Let's start at the end of the problem and work back for a moment. Here's the circle. You say to yourself, where is the center of the circle? In this case, it's at 3, -1. And what is the radius? So you count 1, 2, 3, 4, 1, 2, 3, 4. The radius is 4. So that's the key information that you need right there. Now, let's keep working backwards. What equation would give you a center at 3, -1 and a radius of 4? Well, let's go up here. It would be in parentheses x minus the x value of the center and y minus the y value of the center. Now, minus a negative is, of course, plus. All right, be careful about that. Where did the 16 come from? Well, the 16 is the radius squared. If you have the 16, you take the square root to get the 4. All right. The original problem started off like this. We rearrange our terms, put all your x terms together, leave a space. Put all your y terms together, leave a space, and move all the plain old numbers to the other side. So we've just rearranged things. Now, the mystery is, how do you turn this equation into this equation? They have to be equivalent, but they sure look different, don't they? All right, that's the magic of completing the square. What you do is you go to the plain old x term. You've got x squared minus some x's. Take half of that coefficient. Half of -6 is -3. I'm going to write that down, and I'm going to remember it. We're going to use it 2 different places. The first thing you do with it is you square it. -3 times -3 gives you +9. All right, well, we can't just go and change everything by adding a 9 there. If we add a 9 to one side of the equation, we have to add a 9 on the other side of the equation. All right, let's do the same with the y's. We've got them all grouped together. Go and find the plain old y term. Find its coefficient of 2. Half of 2 is 1. And you take that 1 and you square it. Careful squaring 1. Don't say that it's 2. People do that. 1 times 1, of course, is just 1. Now, you take all your x's, include, I almost forgot to add 1 to the other side. Oh my goodness, we need it there, don't we? All right, now, we're getting closer to what we're looking for. We're looking for the circle in a form where we can graph it easily. 6 plus 9 is 15 plus 1 is 16. Hey, that's the radius squared. Now, where did this come from over here? How did we change? Well, we've factored it. And these always factor the same way. We could go through the whole process of doing a diamond and factoring it that way. But what the heck, we always know it's going to be x or y, and then you put this number right here. Half of -6 is -3. Look at that, -3. If we squared this, x minus 3 times x minus 3, it in fact would equal x squared minus 6x plus 9. All right, how about with the y's? Remember we took half of 2, which was 1. Look down here, y plus 1. If we squared y plus 1, we would end up with y squared plus 2y plus 1. Now you might say, oh, I'm going to get ever so efficient, and I'm not even going to write this step. I'm just going to take half of this and put it here. You'd better write this, because this 9 here tells you what you have to add to the other side. And this 1 here, which I almost forgot, and you might too, that tells you what you have to put on the other side. All right, once it's in this form, it's a piece of cake to graph it. The center is at 3, -1, and the radius is the square root of 16. Hooray. Now my other problem I'd like to work with you, and you'll see these on this week's quiz also, is a system. You'll be asked to solve a system that looks something like this one here. All right, well, we know the top equation would give you a circle. The center would be at 0, 0. Nothing's added or subtracted to the xy. And the radius would be the square root of 160. This would give you a line. So where does that line cross through the circle? Well, the answer way down at the bottom is where the line would go through the circle, at these 2 points. But how do we get there? Well, we start by using substitution. If y is equal to 3x, I'll substitute 3x in for y. Wrap it in parentheses, because when you square it, you square the 3. 3 squared is 9. This is the mistake that some people will make, not in your class, no. We'll add our like terms together. One of these plus 9 more gives us 10 of those things. The x squared is still x squared, not x to the 4th. No. Divide off the 10 from both sides, and then take the square root of 16. But when you do, remember, in an equation like this, you have to consider both the square root of 16, which is 4, and its opposite, which is -4. Why its opposite? Well, let's look. If we took -4 and actually squared it, negative times a negative would give you a positive. So here we have to consider both the +4 and the -4. Well, that's your x value. I've got 2 x values. I have x values of 4 and -4. Those are the x values in your answer. Now, once you have these values, you substitute them back into, you could use either equation. The second one looks a heck of a lot easier. So I'm going to take y equals 3 times 4, which is 12, of course. Now, the +12 this time goes with the +4. +4 gives you +12. Those go together. The negative 4 over here, when I substitute that into the same y equals 3x, if the x is negative 4, I get negative 12. And those two must go together. So what have you found? You found the points of intersection where the line would cross through the circle. That's the kind of stuff on your quiz. Hey, I've got one more fun thing to show you, and that has to do with finding the center of a circle. Here I drew out a nice big circle. Where's the center of it, though? Sometimes it would help to find that exactly. So here's a nice technique. Take a right angle and fit that on there and make it an inscribed angle. Remember what an inscribed angle is? That is when the vertex of the angle is on the actual circle. That's pretty close. That is a right angle, which means it's 90 degrees. Well, if it's 90 degrees, remember that the arc it intercepts is 90 times 2, 180 degrees, which would mean that if we connect these together, we have got ourselves a diameter. That's a diameter of the circle. It goes right through the middle. The center is somewhere along here. Let's do it again. Using the right angle again, and I'm gonna fit my right angle on here. I could put it anywhere I wanted. So I'll make this the vertex of another right angle. So again, I've got myself an inscribed angle. Again, this is a 90-degree angle. And so it intercepts an arc that's 180 degrees, halfway around the circle, of course. And I'll connect these two. When I do that, they cross at one point. This point here where they cross, right here, is the center of the circle. That's how you can find the center of the circle. Now, just to add to the fun, let's take and draw another circle using the same center. I could make it really big and go outside, or I could make it on the inside. And let's go around using a compass maybe, using that center. Try to make that nice and dark. So I have a concentric circles. Concentric circles. The little one in black and the big one in red are concentric circles. And if you draw just that, as I did over here, the green circle and the red circle, concentric circles are called you guessed it, a corona. It's the Spanish word for crown. And I don't really know why that's the name of the virus we are dealing with right now. Maybe someone could find out and explain that for extra credit. Hey, now on Thursday morning, when you check the geometry website, you will find the quiz. If you print that out, work the quiz, and mail it to me, I'm going to grade it as an actual quiz. Please don't cheat. And please return it to me by Friday afternoon. Why don't we say 4 o'clock? So you have all day Thursday to work on it and Friday up until 4 o'clock. Can you do that for me, please? Thank you.